So, hello, hi everyone. Welcome to this Tune the Brand. This is your Sebastian. Today topic is magnetic effects of electric current. So tomorrow is the last exam. So this is the last topic which I'm going to explain. So we covered all the topics and so problems. Once I get revise all the topics. Okay. So this is the last topic. From morning onwards, light reflection, diffraction, human in colorful world, electricity, and coming to the magnetic effects of electric current. So this is the last topic. So here you can see magnetite. Magnetite is the natural magnet. Magnetite is a natural magnet which occurs from earth crust. Okay. So magnetite is a natural magnet or lodestone. Lodestone is a leading stone. Okay. So when people are moving, so in long ago, so people are moving on oceans. So they can't able to identify in which direction they have to go. So that time they will use this one, this stone. So as a for the directional purpose. Okay, so it shows the direction. So anyway, if you suspend up this stone, always it shows north and south direction. So it is a magnetite, natural magnet which occurs from earth crust. Coming to the artificial magnets, so there are so U-shaped magnet, dumbbell-shaped magnet, cylindrical magnets, spherical magnet, and coming to the bar magnet, like the different types of magnets are there according to our industrial purpose, according to our uses. So we design. Okay, those are called artificial magnets. Artificial magnets, okay, are man-made magnets. Artificial magnets are man-made magnets. So here, around the magnet, magnetic field will be there. Around the magnet, the magnetic field will be there. So the magnetic field will be in the form of field lines. Magnetic field will be in the form of field lines. Okay. So here, a magnet has two poles. Magnet has two poles. One is north pole, another one is south pole. One is north pole, another one is south pole. And a magnet has two poles has equal strength. So north pole and south pole, both poles has equal strength. So if you drop the magnet, the magnetic materials will attract more at the ends, like at the poles, than in the middle. Okay, so magnetic strength will be more at the poles than in the middle. So coming to the bar magnet, so I'm talking about bar magnet. So when you are taking the bar magnet, if you consider the bar magnet, if you drop the magnet into the sand, okay, the magnetic material will attract, the magnetic material will be attracted at the ends of the poles, at the ends of the, so like at the ends of the bar magnet, those are called poles, north pole and south pole. So magnetic materials will attracted, so magnetic will be attached at the poles than in the middle. Understood or not? So the around the magnet, magnetic field will be there. Around the magnet, magnetic field will be there. So the magnetic field will be in the form of field lines. In the form of field lines. So around the bar magnet, the magnetic field will be in the form of field lines. Field lines. So I'm taking here. So this is the bar magnet. I'm taking this the bar magnet. So we are talking about bar magnet. Okay, this is north and south. This is north and south. So around the bar magnet, magnetic field will be there. So how the field will be? So point number one, magnetic field. So we will talk about a magnetic field, and coming to the point number two, magnetic field lines, magnetic field lines, magnetic field lines, magnetic field lines. So magnetic field, the region around the magnet in which magnetic field, the region around the magnet in which magnetic force exert. Okay, so if you are taking this a bar magnet, so if you take this a bar magnet, around this magnet the magnetic field will be there. Around this magnet the magnetic field will be there. Until certain distance only the magnetic field will be there. Okay, beyond the point, if you take this one, so like if you consider this a magnetic material, so until certain region only, until certain distance only, this magnet will attract the magnetic material. So beyond the point, the this magnet will not influence, will not attract. So no force will exert on other magnetic materials, on magnetic materials. It does not act any force on magnetic materials. Within the region, this magnet will attract, this magnet will influence, this magnet will so act force on it, right? So beyond its limit, it won't. Okay, so now you can consider, so magnetic field will be in the form of field lines. Magnetic field will be in the form of field lines. Understood or not? Magnetic field will be in the form of field lines. Okay, so how the magnetic field, so around the bar magnet, the magnetic field will be north to south. Inside of the bar magnet, the magnetic field, okay, south to north. So around the bar magnet, the magnetic field will be north to south. So here you can take the outside of the bar magnet, the magnetic field will be from north to south. So you can observe here. Okay. So here outside of the bar magnet, the magnetic field will be like this. Coming to the inside of the bar magnet, the magnetic field will be, okay, so south to north, So this is very, very important. These are closed loops. Magnetic field lines are closed loops. They will not intersect. These field lines never intersect. Point number one. So these field lines emerge out from north, merge at south. These are closed loops. Emerge out from north, merge at south. These are closed loops. So the magnetic field lines are from north to south. Okay, so outside of the bar magnet, inside of the bar magnet is south to north. So these are very closed loops. These field lines never intersect. If it is intersected, what happens? So compass, a compass is nothing but small magnetic needle is presence inside of it. If you suspend the magnet, it always shows north and south direction. If you suspend, always it shows north and south direction. If you want to identify the magnetic field at particular point, you have to draw the tangent to the magnetic field lines. Okay, if you draw the tangent to the magnetic field lines along the direction, the magnetic field will be there at that particular point. So if I am drawing like here, so if I am drawing the tangent to the magnetic field line, so along the direction, the magnetic field will be there. Along that particular direction, the magnetic field will be there at that particular point. Understood or not? At particular point, the magnetic field direction. Understood? Outside of the bar magnet, anyway, no magnetic field will be from north to south. Inside of the bar magnet, south to north. Clear? But if you want to identify the magnetic field at the particular point, you have to draw the tangent. To the magnetic field line. So then you can identify. Understood or not? So that is very clear. Next one. So these field lines never intersect. If it is intersect, so what happens? So this is the field line. If it is intersect, so this is the direction of the magnetic field. This is the direction of the magnetic field at this point. So compass should show at a time two directions. It's not possible, right? Compass cannot show at a time two directions. Compass will show only one. So one direction, that is north. So north and south. So like that it will show. So it cannot show two directions at a time. So that's why it is not possible. Understood or not? So this is very, very important. Magnetic field lines properties. And coming to the next one. So if the current is passing through the conductor, it behaves, it acts as a magnet. If the current is passing through the conductor, it behaves, it acts as a magnet. So I am taking the straight conductor. So this is a straight conductor. Like this I am taking. Like this I am considering. Like this. Okay. So that is connected to the circuit. Like here. So I am taking here this ammeter, rheostat here, and that is connected to the battery. Okay, so switch I am taking here. So we can take switch here also, fine, no problem. So like this I'm considering. Okay. So now current is passing. Current is passing. The current is passing through the straight conductor. Okay. So around this one magnetic field will be produced like this. So this is the cardboard. This is the cardboard. Here like this I'm taking. So if you place the compass here, if you place the compass over here, okay, so we can identify the magnetic field direction. We can identify the magnetic field direction. Understood or not? So this is a straight long copper conductor. When the current is passing through the conductor, so it produces, it behaves as a magnet. Magnetic field will produce around it. So the magnetic field will be in the form of concentric circles. The magnetic field will be in the form of concentric circles. So like this. Okay, magnetic field will be in the form of concentric circles. So like this I am taking. Okay, so in which direction the magnetic field will be there? So the question is, in which direction the magnetic field will be there? How can you identify the magnetic field around the current carrying conductor? By using right hand thumb rule. By using right hand thumb rule, we can identify the magnetic field around the current carrying conductor. Okay, so if the current is passing, so if you are taking this is the current, so current carrying conductor, so current is passing upward direction. If you place the thumb, along the current carrying conductor, so Maxwell's Cork rule also same only. So current carrying conductor, along the current carrying conductor, if you place the thumb along this one, so you can take the thumb along the current carrying conductor, you have to place the thumb. Curly fingers, folding fingers, wrapping fingers. Curly fingers represent the magnetic field direction. Magnetic field direction. Understood or not? My curly finger shows magnetic field direction. So if the current is passing downward direction, that magnetic field will be so like this. Understood? So the magnetic field will be like this. Is it clear? Magnetic field. If the current is passing upward direction, how the current will change? If you change the battery polarities, automatically current direction also changes. Understood or not? So along the current carrying conductor, if you place the thumb, so along the current carrying conductor, if you place the thumb, okay, so curly fingers, folding fingers represent the magnetic field. Curly finger, folding finger represents the magnetic field. Is it clear? I hope it is very clear. All right. Yes. So follow the same. Okay. So follow the same. Yes, all the best. So best of luck. So lots of best blessings to you all. Okay. So definitely you'll do good. So paper will be easy only. Don't worry about the exam. So paper will be easy. So you'll do good. Okay. So believe yourself. Be confident. So be confident enough to write the exam. Don't worry. Don't take too much tension. Nothing will happen. So everything goes well only. So prepare well. So believe your preparation. Concentrate on your preparation. So be strong. Okay. So that's enough. Only thing is believe yourself. Believe your preparation. Okay. Then automatically you'll do good. Right? Yes. So coming to the next one. Here, if the current is passing through the conductor, so it will produce magnetic field. So how can you identify the magnetic field around the current carrying conductor? By using right hand thumb rule. So if the current is passing, so curly fingers, folding fingers represent the magnetic field. If the current is passing downward direction, so along this direction. Okay. So if the current is passing towards me, if you wrap the fingers along clockwise direction, this is a clockwise direction. Along the clockwise direction, magnetic field will be. So if the current is passing towards you, so this is anti-clockwise direction. Understood? Anti-clockwise direction. So like that you have to identify if the current is passing through the conductor. So around the conductor, magnetic field will be produced by using right hand thumb rule. So Maxwell's Cork rule also same only. Corkscrew rule. So same only. Okay, so around the current carrying conductor, if you place the thumb, curly fingers, folding finger shows. represent magnetic field direction. Understood or not? So this is enough. Now one more point. So here if you are taking this is the north and south and east and west. So if the current is passing north to south, the deflection will be the compass towards east. Towards east. And so yes, definitely. So if the current is passing from south to north, the deflection will be towards west. Towards west. Understood? Towards west like that. So if you change the current direction, automatically magnetic field direction also changes. If you change the current direction, magnetic field direction also changes. Magnetic field direction also changes. So that is very, very important. So by changing the current direction, magnetic field direction also changes. Keep in mind, MCQ's point of view, very, very important. Very, very important. Okay. So then we can go to the next one. That is, so loop. Loop is very, very important. Loop and coil. So coil is number of turns. Yeah, already I'm continuing. So already explaining. So it's continuing chapter, Sabani. So next one. So loop I am taking. This is the loop. So this is the loop. So I am taking this the loop. So positive terminal, negative terminal, current is passing. Current is passing. And here one point. So we know that. So we know that. So we know that if the current is passing through the conductor, magnetic field will be produced. Magnetic field will be produced. So here you can see. So like this I am taking, this is the north and the south. So this is the north. This is north and this one is south. So north and south, see. So if you by using right hand thumb rule, we can identify the current. So by using right hand thumb rule, we can identify the magnetic field direction. So as you move towards the center, so this is the center. Exactly at the center, the magnetic field will be uniform. It will become uniform. All the best. Lots of blessings from me to you. Okay. All the best. Definitely, you'll do good. Okay. So now we can see. So when the magnetic field lines increasing at the center, it will become parallel lines. Automatically, it will become uniform magnetic field lines. So one magnetic field will be added up to another. So at the center, more magnetic field will be there. Uniform magnetic field will be there. So then at the circumstance, compared to the circumstance, so at the center, so uniform magnetic field will be there. Understood? So more magnetic field will be there at the center. So they will ask the question. So in circular loop, this is circular loop. So remember, this is the circular loop. So circular coil will be there. So number of turns are there. So inserted to the cardboard. So connected to the circuit. So magnetic field will be produced. Okay, if you sprinkle the iron particles, automatically if you tap, so the magnetic field will be produced. Okay, the magnetic field will be. So the iron fillings arranged in the form of magnetic field. Okay, so iron fillings. Okay. Understood? Next one. So this is the circular loop. Next one, so we'll discuss about solenoid. Solenoid is very important. Definitely it will come for 3 marks. Solenoid, very important question. Very important question. So take a straight copper wire. Bent in the form of cylindrical loop. So bend like this. If you are taking a straight wire and bent in the form of cylindrical shape. Okay. Yeah, this is CBSE only. CBSE grade 10 physics. So 1, 2, 3, 4, 5. So like this it depends. So you can take. So you can consider like this. And here also. So this is the battery switch. Okay. So now it acts as a magnet, bar magnet. So same like. So this is for CBSE ma. CBSE grade 10 physics. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are 9 lines. So 3 lines, 1 and 2 and 3, and coming to 3 lines below, 1 and 2 and 3. Okay, 3 lines in middle. So like this and here. Okay, so if the current is reaching to the point, so here current is reaching to the point and here also, so current is leaving this point. So this is the south and this one is north. So magnetic field also leaving away. So reaching. So here you can take like this. Okay. So observe, some people they will draw the directions. So here they will draw like this only. Below they will draw in reverse manner. Okay. So magnetic field must leave from north and reaches to south. So wherever you are drawing, so make sure that magnetic field is leaving that point. Okay. So leaving that pole and so reaching to the south. That is very important. So make sure that while drawing, so that arrow marks are correct. Okay, arrow marks are proper. So this is textbook diagram only. So I am not taking anywhere. So from textbook reference only. From textbook only I am drawing. Okay, so here taking straight copper wire, so bent in the form of cylindrical shape that connected the battery. It acts as a magnet, that is called solenoid. Okay, so it's same. It acts like a bar magnet. It's act like a bar magnet. So if you are taking a bar magnet, this is a bar magnet. So this is north and this is south. This is north and south. So bar solenoid act as a bar magnet. Point number 1. So point number 2. So solenoid has poles, north pole and south pole. And coming to the point number 3. Okay. So here magnetic field emerge out from north, merge at south. Here also same thing. But coming to the differences. So here solenoid magnetic field can increases or decreases by changing the strength of current. So if strength of current is more magnetic field will be. Strength of current is less magnetic field will be. Depends on current passing through the solenoid. Point number 1. So here magnetic field is fixed. We can't change the magnetic field. Magnetic field is fixed. And point number 2. Here, so we can change the poles. North pole, south poles are there, right? Here also, north pole, south pole. For bar magnet, we can't change the poles. But solenoid, we can change the poles. How? By changing the battery. Okay, no? So by changing the battery. So this side, so here current is moving like this. If you interchange the battery, so current will move like this. Then automatically poles will interchange. Okay. So battery polarity. So poles, north pole, south pole can be interchanged. Here we cannot interchange. So these are fixed. Understood? So here, so magnetic field depends on magnetic field depends on strength of current, very very important, strength of current and number of turns and the air gap. So how much gap you are keeping, so it depends on it also. So number of turns is main. Okay, so when you are increasing number of turns, more magnetic field will be produced, and more current if you send also, more magnetic field will produce. Understood or not? I hope it is very clear. So this is about solenoid and this is about bar magnet. So now we will discuss about a current carrying conductor placed in the external magnetic field experience the force. Okay, so just check once. A current carrying conductor placed in the external magnetic field experience the force. Okay, so now you can see here, I am taking the aluminum rod here, this thing AB. So it is placed in the external magnetic field, that is north and south. So this is north and south. So here so here you can see current is passing, magnetic field will be produced like this. Understood or not? So if you place the current carrying conductor in the external magnetic field, experience the force. So by using what tool we can identify the force acting on the conductor? So current carrying conductor placed in the external magnetic field experience the force. Yes or no? Yes. So now in which direction that current carrying conductor will move? By using what rule we can identify? By using Fleming's left hand rule. We can identify the force acting on the conductor. Point number 1. So index finger represents the magnetic field. So middle finger represents the current and thumb finger represents the force acting on the conductor. So here this is the magnetic field, current direction. So into the board the conductor will move because thumb is showing inwards. Understood or not? So Fleming's left hand rule. So I hope it is very clear. So magnetic field, current direction, thumb showing into the board. Is it clear? So along the thumb direction the force will act on the conductor. So this is about Fleming's left hand rule. Understood or not? Is it clear? So that's enough. Next. Short circuit, the direct contact of live wire and neutral wire takes place, then heavy amount of current will be drawn from the mains. That is short circuit. Coming to the overloading, high voltage appliances on at a time, then heavy amount of current will be drawn from the mains. So that is overloading. And coming to the next one, live wire. So point number 1, live wire. Okay, live wire. Live wire is 220 potential and red insulation, so red color. And coming to the second one, neutral wire is 0 potential and black color. Okay, black color. And coming to the third one, earth wire 0 potential, So green color, green color. Understood? So very important. So the difference between live wire and neutral wire is live wire and neutral. So the potential difference between live wire and neutral wire is 220. So this is very important point. Very important. Very essential point. The difference between live wire and neutral wire is 220. The potential difference between live wire and neutral wire is 220. The potential difference between live wire and earth wire also 220 only. But the potential difference between neutral wire and earth wire is 0. Neutral wire and earth wire is 0. So very important. Make sure that these points you are keeping in mind while you are attempting MCQs. Okay. So MCQs point of view, these points will come. So keep in mind. Okay. So very important. Very important. So that's enough. And coming to the safety measures, fuse one and earthing. Okay. So when extra current goes to the circuit, so it melt and breaks the circuit. Okay. So fuse will melt and breaks the circuit. It safeguard the appliances. And earthing also extra current is there. Then it sent to the ground. Understood or not? So these are the safety appliances, safety measures we are taking in the household. Is it clear? Okay. Done. So these are the points. So few questions we'll discuss related to magnetic effects of electric current. So just one